Today we're going to focus on solving inequalities that contain both positive and negative numbers. Copy down your target, pause the video, complete the warm-up at the top of your notes. You may have to fit it in on the margin a little bit, and then press play again. Okay, with the warm-up, hopefully you figured out that it would have had to have been about $20 at the start. We're seeing a gain of 1, a gain of 3, and a gain of 2, but a loss of 2 and a loss of 1. So really, this cancels this, and this cancels this. Wherever she was on Monday must have been 3 less than where she wanted to be because she gains 3, so it's $20. With solving inequalities, our goal is still to isolate the variable. It's just on one side of the inequality symbol now instead of equation. The reason, or whenever we solve an inequality though, we have lots of solutions. You've seen inequalities before. Think about it, if I have x is less than 5, how many solutions are there to that? Well, x could be 6, right? I'm sorry, x could be 4, right? 4 is less than 5. Okay, so 4 is a solution. What else could be a solution? 3, 2, 1. That's supposed to be a 3. Sorry about that. And those aren't the only solutions. 0, negative 1, negative 2, negative 3. What about all the numbers in between here? What about 3.5? What about 3.678? What about 3.001? So there are an infinite number of solutions to an inequality. We can't possibly list them all out. These are only a few to the solutions to this. So a graph shows all of the solutions of the numbers, shows all of the numbers that will satisfy the inequality. Okay, so make sure you copy that down. We should be familiar with these symbols: less than, greater than, less than or equal to, or greater than or equal to. And remember how to show them on a graph. So guys, if you're graphing less than or greater than, it's going to be an open circle because we're not including that number. But if we're graphing less than or equal to or greater than or equal to, it'll be a closed circle, so you actually fill it in because you're including the number that you're graphing. Same thing up here. Okay, so maybe put yourself a little reminder there. If you haven't done this already, these are how you would graph them. Let's solve these inequalities just like equations, okay, with these first two. You want to solve, you want to get x by itself. So we want to isolate this x. What's happening to x? I'm adding 3. How do I undo that? I subtract 3. When you subtract 3 from both sides, what do you have left? You're left with x is less than 147. There's your solution. Now we just have to graph it. When you do your graphs, guys, make sure you check with your classroom teachers to see what they want on their graph. For me, I always say you really just need 3 numbers, and 0 does not have to be shown on the number line. But every teacher's different. You know, your teacher might want to see 5 numbers, so check with them. I'm going to put 147 right here at the center. Then you have to put at least 1 less than and 1 greater than. Doesn't mean you have to use every tick line. So because these numbers are big, I'm going to space it out. I'm going to say, okay, every other one is going to go down a number. So this is 146. This is 145. Over here is 148. And over here is 149. Okay? You don't have to number every single tick line as long as, see, I'm saying this distance of 2 spaces is 1 unit. I kept that constant over here, and I kept that constant all the way up my number line, okay? So I have a couple numbers on there. To graph this, I want to show that it is any number less than 147. So what are some of my solutions? 146, 145, really 144.5, and all the points there, right? Is 147 less than 147? Is that true? If I said you have $147 and your sister has $147, do you have less money than her? No, that's not true. Those are equal. So we want to put an open circle to say, hey, this number is not a solution, but every number to the left of that is less than that. So shade to the left of that open circle. Make sure you shade an arrow too, because we're showing it goes on forever. Okay? Let's try this other one over here. 2x is less than or equal to 10. To get x by itself, I would divide both sides by 2. I'm left with x is less than or equal to 5. Again, get that 5 on the number line. Maybe I'm going to do 6, and then I'm going to do 4, okay? And you can count by 2s or 3s or whatever you want. Just make sure 5 is on there. I'm including 5 now. 5 is less than or equal to itself. It's equal to it. So I want to fill that in. Less than or equal to gets a filled in circle. Same with greater than or equal to. All the numbers less than 5, so I'm shading again to the left. If it was greater than, I'd be shading to the right. All right, so these two inequalities, you probably have solved some like this in the past. You might remember them. What we need to practice now is solving with negatives. So here's some new rules. Multiplying or dividing by a negative number changes the sign of the inequality. The inequality symbol. You have to flip the sign. Remember, this is only if you are using multiplication or division by a negative. Here's an explanation real quick on why this works. Try to stay with me here. Let's just start with a couple numbers. This is 0, and I have 2, and I have 3, right? Well, you could write an inequality with 2 and 3. You could say that 3 is more than or greater than 2, right? But now let's take that inequality statement and let's multiply it by a negative number. I'm just going to keep it real simple. Let's multiply it by -1. When you multiply both signs by a -1, now -3 and -2 are your results. So -3 would be over here, and -2 would be right here. So I have these two new points. What inequality symbol, so this one became here, and this one became, oops, sorry, and this one went to there. What inequality symbol would have to be right in between there to make sense? Which one's larger, guys, -2 or -3? -2. So actually, 3 is greater than 2, but -3 is less than 2. When you multiply by this negative, anytime you multiply by a negative number, it flips the sign of that number. Guess what? You also have to flip the inequality symbol, okay, to keep it making sense, to keep it the same. So let's try these two examples, and then I want you to explain to me the difference between problem 1 and problem 2. In problem 1, what would you have to do to get x by itself? In problem 2, what would you have to do to get x by itself? Do you need to flip the sign in both of these? Take a second, solve these, pause the video, flip the page and answer number 3, and then press play. On this first one, you would just be dividing by 8, so we would not need to flip the symbol. X would be greater than -9. On the second one, you would divide by -8. Now you do need to flip the symbol, so it immediately gets flipped to a less than symbol. We're left with x is less than -9. Be careful when you number your number lines here. Remember that the negatives get more negative to the left, so -10, -9, -8, -7, -6. It's going kind of opposite of what you would expect. -10, -9, -8, -7, okay? To graph these then, on this one we would have an open circle and the shading to the right. On this one we would have an open circle and the shading to the left. So what is the difference between 1 and 2? Hopefully you've explained it in your own words. You would not have to flip the sign in the first one, okay? Read over that. Okay, great. Let's try 2 more, and then you're going to try 2 more. So I'm going to do 4 and 5. I'll get you help with these fractions and decimals, but you're going to try 6 and 7. So on 4, we're still solving for k. We want to get k by itself. I would have to subtract 14/3 from both sides, right? I'm adding 14/3, so let's undo that. Now this is going to take a little work over here with your fractions. So I'm going to do it over in the margin, okay? You have 5 and 2/3, and you're subtracting 14/3. How are you going to do this? Well, one's improper and one's mixed, so you need to make them both the same. I think it's best to take them both to be improper fractions. So 5 and 2/3 is the same as 5 times 3, 15 plus 2, 17/3 minus 14/3. Now they already have a common denominator, so you're good there. You get 3/3. Ooh, guys, what's a better way of writing 3/3? 1. So back to your inequality, these are going to cancel on the left. What do you have remaining on the left? Just a k. Keep your inequality symbol. We didn't multiply or divide by a negative. And 5 2/3 minus 14/3 is going to give me 1. Get that graphed. 0, 1, 2. I skipped the same amount between each one. Open circle because we're not including 1, but k is any number greater than 1, so I'm shading to the right. All right, for number 5, x minus 2 is less than or equal to negative 3.5. How would you get x by itself? You want to isolate it. We have minus 2, so we would need to add 2. Not so bad here. Canceling on the left, we have only x now. We didn't multiply or divide by a negative, so we're going to keep that inequality symbol. Watch the operations here. We're adding two numbers. Same signs or different signs? Different signs. Find the difference. Be 1.5 or 1.5. And then you keep the sign of the the larger digit, so it'd be more negative. So it's a negative 1.5. Remember, you're counting from 0, so I'm going this way now. Negative 1, negative 2, negative 3. Negative 1.5 would be negative half, negative 1, negative 1.5, right here, in between negative 1 and negative 2. X is any number less than that. So what's less than this? You can always pick a point and try it. Maybe you pick negative 3. Is negative 3 less than negative 1.5? It sure is, so it's shading to the left. I should mention, guys, for a check step, you can always pick one of the points you shaded. Right here, I shaded 5 or 10. So on this one, if I plug it in, is 10 greater than 1? Yeah, if I plug in 10 here, 10 plus something, is that going to be more than 5? Yeah, I don't even have to worry about the fractions because 10 is already more than 5, and I'm adding to it. Okay, I want you to try 6 and 7. Pause the video and try these two, and then I'll put the answers up. And then 8 and 9 you're going to do on your own, and I will post a picture of these of the solutions after the video. That's a little extra challenge for you. So pause the video now, try 6 and 7. Make sure you check if you have to flip the inequality symbol, and make sure you try one of the points that you shade, even if it's just mentally. Okay, pause the video. You did 6 and 7. Let's check out what you got. Here are what my two graphs look like. Check the work. Make sure you show all of your work, guys, exactly what operations you're doing. Both graphs have open circles. I need to fix that. Both graphs will have open circles. There we go. But they are both shaded to the right. All right, if you have any questions, please see me or your teacher. Make sure you try 8 and 9 as a challenge. Let's see if you're up to it. The first one, you're going to have to write your own inequality, and the second one, we've got parentheses, we've got absolute values, we've got distributing. Let's see who can handle it.